Lesson 69, proper form of scientific notation. So when we have a number like 200, for scientific notation, if you remember, you have to write the first non-zero digit that you see in the number. In this case, it's a 2. And then you put times 10 to the, and you have to count how many numbers are past the 2. In this case, it's 2, so it'll be 10 squared. So 2 times 10 squared would be proper scientific notation. If we started with 3 thousandths, we would have to write the first non-zero digit that we see, which is a 3, times 10, and now since it's smaller than 1, we're going to have a negative exponent, and it's just how many times do we move the decimal so we get it to the right of 3, the end of 3. So we have to move it 3 times, so it's 10 to the negative 3. Now, when we have, just because we have times 10 to the something power, does not mean it's in proper scientific notation. So this is not in scientific notation. So we have to rewrite 4,600 in scientific notation. So we write the first non-zero digit, which is a 4, and then 0.6. So the non-zero digits we write in here, unless there's zeros between non-digits. Anyway, we stop at the 6. And this is going to be 3 numbers past the 4, so it's times 10 to the 3rd. Now this just means 4,600, but we still have times 10 to the 5th. And if you remember, when we multiply numbers that have the same base and different exponents, we just have to add the exponents. So this is going to be 4.6 times 10 to the 8th power. So that will be the proper scientific notation. If you look up here at the beginning, if you know the decimal goes there, we have to move it to the right 3 times. So we add 3 to the 5. No, sorry, that didn't make sense. I take it back. If you move the decimal, we had to move it 3 times to the left to get it here. So then we add 3 to the 5. So if you move it, if you have to move it to the left, then you add 3. Okay, so what if we have, here's some examples. 230 times 10 to the 8th. So we have to move our decimal 2 times to the left. So it becomes 2.3 times 10 squared will give us 230 times 10 to the 8th. So we have 2.3 times 10 to the 10th. So we had to, if you move the decimal to the left to get it in proper scientific notation, add that number to the exponent. So you just add how many times you moved it to the left and add it to the exponent. Here's another example where we don't have the decimal in the right place, so it's not proper scientific notation. Now we have to move it 1 time to the right to get 3.2. In order to do that, when we move it this way, it's going to be to the negative first, which becomes 3.2 times 10 to the 4th power. So since we had to move the decimal to the right, you need to subtract from the exponent. Okay, that's the end of the lesson. We're going to do some practice set so that you can get used to adding and subtracting. So if you had to move the decimal left, then you just add the number of the exponent. If you have to move it to the right, you subtract how many times you moved it from the exponent. That's it.